2006, NASA launched the New Horizons spacecraft to explore Pluto, which at the time was considered the 9th planet of the solar system. Its goal was to uncover the secrets of that mysterious dwarf planet, spinning in the icy silence billions of kilometers from the Sun. After a long journey of 9 years, it reached Pluto in 2015 and made history. But here's the interesting part. The data it sent is still being analyzed, and this data shows that Pluto is not as calm as we thought. Some scientists even say it might be a living planet. But how is that possible? Talking about movement on an ice-cold planet sounds a bit strange, doesn't it? I know it sounds absurd. With its famous heart-shaped surface, Pluto is actually a cold but charming icy world. Its surface is rich in frozen nitrogen and carbon monoxide, but something else may be going on beneath its layers. In fact, it has long been known as the largest and most striking object in the Kuiper Belt. However, when other objects similar in size to Pluto were discovered in the same belt in the 1990s, astronomers began to ask, wait a minute, do we really call this a planet? And in 2006, the International Astronomical Union changed Pluto's status to that of a dwarf planet. But that decision couldn't overshadow Pluto's mysterious and captivating nature, because the images sent by New Horizons revealed something never seen on any other planet before: gigantic, rugged, crater-free icy volcanoes. Straight out of science fiction, but real. Normally, when you look at a planet's surface, especially in a region like the Kuiper Belt, where asteroids are abundant, you expect to see craters. But in these volcanic areas, there are almost no craters at all. And that's very strange. There are also no signs of plate movements like the ones that form mountains on Earth. So how were these mountains, hills, and surface wrinkles formed? The answer: most likely in the recent past, at least on a cosmic timescale. About 2 billion years ago, a series of cryovolcanic eruptions, meaning ice-spewing explosions, took place. Among these volcanic structures, two giants stand out in particular: Right Mons and Picard Mons. Right Mons is nearly 150 kilometers wide and 5 kilometers high, with a massive 50-kilometer wide depression at its center. Picard Mons, on the other hand, reaches about 7 kilometers in height and spans up to 225 kilometers in diameter. Although Pluto is only about 1/6 the size of Earth, it has enormous ice volcanoes on its surface that rival the size of Mauna Loa. These volcanoes are located to the left of Pluto's heart-shaped region, southwest of Sputnik Planitia. It appears that the surface is covered with water ice, and that material from repeated eruptions has built up into swollen, uplifted formations. The fact that the ice is not nitrogen or methane, but actual water, indicates that the activity originates from deep within. However, Pluto lacks a conventional heat source capable of sustaining such powerful volcanism. Neither tidal forces are sufficient, nor is radioactive heat production strong enough. The most likely scenario is that Pluto's interior has not completely cooled. This internal heat is thought to have potentially created a liquid subsurface ocean beneath the thick ice crust. Since New Horizons passed by Pluto for only a single day, it's unknown whether these volcanoes are currently active. If they are active, it would be a strong indication that liquid water still exists on Pluto. Moreover, such large cryovolcanoes spread over such a wide area have not been observed on any other celestial body. In other words, even though Pluto appears frozen, it may still be geologically alive, and it might even be hiding a secret ocean beneath its surface.